This is mainly from last semester. Combining like terms, you may have to distribute. We distribute when we have a number in front of parentheses, right? All right, let's combine some like terms then. Here I have 8x squared and a 7x squared gives me, that's right, 15x squared. Nothing I can do with the minus x cubed, so minus 8x cubed. Now if you want to put this in standard form, have at it. Negative 8x cubed plus 15x squared. You don't have to at this point. Either one is fine. Number 2 is that review. When I have to distribute, I have a number out in front, distribute over the parentheses, which means I'm going to have to multiply it to each term inside. 7x times x, 7x squared, good. 7x times negative 3, negative 21x. That's it. I can't combine those because they're not like terms. This one has 2 x's in it, and this one only has 1. Okay. Let's see. I can combine a few of these. With a 10x squared, a minus 21. Oh, that's a y. No, I can't. I can do the 7x squared. That gives me 17x squared. Yeah, in this case I'm going to add. If that was a minus 7x squared, I would subtract. Okay. And then I have my minus 21y squared. And then I have my plus 31y. Okay. 17x squared minus 21y squared plus 31y. Don't combine these y's. They're not like terms. Yeah, if this was a squared, then I can combine them. Okay, be careful here. This is the number out in front of the parentheses that I'm going to distribute. I'm not going to do anything to the 2x squared. Plus 3x times x. Plus 3x squared, good. 3x times 4. 12x. Combine like terms. I have 2 x's here, an x squared, and I have an x squared here. Good. 5x squared. And this is what I have left. And then they get into some trickier ones here. Yeah, just be careful. You're going to have to distribute the negative sign too. Okay, starts to get a little bit more trickier. Not doing anything with the 5x. Bring it down. As a matter of fact, I'm not doing anything with that 3y too. So bring that down. Negative 2 times x. Negative 2 times y. Good, Cassandra. Alright, like terms. Here's an x. Here's an x. I always like to circle that sign in front too. 3x, good. Yep, there's a plus 3y and a minus 2y. So it's a plus 1y. No, it's not 3x squared because I'm not multiplying them. Okay? In fact, that's exactly what we're going to do next. Okay? When I combine them, when I'm adding or subtracting, I keep the exponent as is. Here's that first rule. When I'm multiplying with the same bases, means I'm going to add the exponent. Okay? Now, these lines here are for an explanation of what's really happening. What you're really doing here is this one has two x's, right? You're multiplying two x's together. And then we're going to multiply it by three x's being multiplied together, right? Okay. And what you're really doing is you count up the x's and you get 5. Yeah, but the shortcut here, the rule is that we're taking x, I'll put a little slash here, taking x, as long as they're the same base, you're going to take the exponents and add them. Okay. That gives me x to the 5th. You don't have to do this. It helps students when we get into division, especially if you do write it all out. Okay? Not so much with multiplication, but with division, it does help. Okay, so let's look at B. I'm not going to write all this out for multiplication. Again, if you want to, that's fine. Does that answer your question with the previous problem, Julian? Because we're not multiplying, we don't add the exponents. Okay. Let's see. This means I'm going to take the x, same base, and I'm going to add the exponents, 6 plus 3. That gives me x to the, good. Okay, now, when I have a coefficient with the x, I always have a coefficient with the x, or any variable. It's just that when it's 1, we don't write it down. Here it's something other than 1. Actually, I should blow this up a little bit. Okay, here my coefficient is 3, and here my coefficient is 4. Now those, I'm going to multiply together. Okay, I'm going to multiply the coefficients, and then I'm going to multiply that by x to the 5 plus 4. So this gives me 3 times 4. Gives me a new coefficient of 12. X to the 5 plus 4. 9. So the long out drawn rule is when you multiply the terms, because each one of these is a term, when you multiply them, you add the exponents. But multiply the coefficients, right? One more rule. What's anything raised to the 0 power? Not the 0. 1. It's going to be on every test, every quiz, every standardized test for the rest of your mathematical lives here at the high school. Okay? It's going to pop up. Maybe not in geometry. Yes. Yeah. Algebra 1 and geometry state law. Then it's also state law that you have to have a 3rd year of math, but it's up to the school district for that one. For our school district, it's algebra 2. Okay. Let's do some practice. Same base. I'm multiplying them. What do I do with the exponents? Add them. And it's going to be x to the 8. Good. How about 11? X to the 13. 12. X to the 15. What about 13? Don't forget, multiply the coefficients and add the exponents. Yep, 15x to the 15th. A lot of 15s. Now don't forget there's a 1 in front of that x cubed, so the coefficients is going to be 8 times 1 times, or just 8, good, 6 plus 3. Yep, 8x to the 9th. Um, 9 times 6. Uh-oh, here's where your times tables are going to come into question, right? I'm okay with that, as long as you use a calculator. X to the 4 plus 3, 7. There's one Algebra 2 teacher that hated learning her times tables. Yeah, I don't know why. I loved them. You guys probably loved Winnie the Pooh at that age. I was loving times tables. 7 times 2? 7 plus 4, 11. Good. Okay, let's do a couple of harder ones here. Getting a little harder. The fonts on this thing is not great. Notice they're using parentheses, they're using little open circles for multiplication, they're using the letter X for multiplication. So just, it's all multiplication, just different symbols, okay? Let's look at, let's look at number 17. The numbers. And this helps too. You start getting a little confused because some of these get pretty long. Put your numbers together, your coefficients, 8 times 2. You can put your x's together, x to the 3rd times x to the 8th. I can do that in multiplication. I can change order. It's commutative. And I got y to the 4th times y to the 5th. Sometimes this helps. 16, x to the, add them, yep, 11, y to the, sometimes it's that one extra step can make all the difference in the world. How about 19? What are my coefficients? -3, 1, and 1. My x's, x to the 9th, x to the 3rd, and y to the 3rd, y to the 3rd. So -3, x to the 9 plus 3, and y to the 6th, not 9. Ooh, if there's no exponent there at all, what is it? A 1, just like the coefficient. If there's no coefficient there, it's a 1. So I have x to the 5th times x to the 1st is x to the 6th. Good. Think you guys can do some of these in your head? Negative 3 times negative 5. Positive 15. X to the 4th, x to the 7th, x to the 11th, y to the 4th, y to the 6th, 10. So if you do enough of these, you could probably skip a few. Off your phone. All right. Any questions on this? Second rule. It's called power to the power. Yes. What if the exponent's outside the parentheses? What do you do if there's a number outside of parentheses? Multiply. Yeah. That's exactly what you're going to do. You're going to multiply each one of these exponents. Okay. I don't even know if I'm going to expand this out because sometimes it gets more confusing if it's expanded out. Let's just look at it this way. You're going to take that 3, distribute it to the 4. What do I get? 12. 3 times 4 is 12. Okay. It's almost easier just to do that than to try to expand it and then, add up the numbers. 5 times 3 is x to the 15th. Now, again, look inside the parentheses here, right? I have a 3x to the 4th. What's the exponent for the 3? If it's not there, it's a 1, right? Okay, so we're going to multiply the exponents. 3 times 1 is what? So I have 3 to the 3. 3 times 4 is 12. Now, you could multiply that 3 out, but at this point, that's not really what I'm testing you on. Okay, the concept is, do you know how to use the power of a power rule? And that means to multiply the exponents. So if you want to leave it at that 3, that's fine. If you want to expand it out, that's also fine. 27x to the 12. Either one of those. So when you use power to power rule, what do? Yeah. Multiply. And please put exponents there. I'm almost done. Stick with me, okay? Then you can do your phone thing. All right, number 9. My number is outside parentheses, so I'm going to multiply the exponents. X to the 6 times 4, 24. Number 10. Exponent 5 is outside parentheses. Going to multiply to each exponent. 20. Y to the 15th. Good. Okay, look inside your parentheses. Anything that doesn't have an exponent has a 1 there. Okay, so 4 times 1, 3 to the 4th, 4 times 2, x to the 8th, y to the 4 times 2, y to the 8th. Okay, look inside the parentheses. Anything that doesn't have an exponent, put a 1 there. Negative 5 to the 1st. Let's see, 4 to the 1. Now, you got to be it's a little tricky with negative numbers. We may get into this, I can't remember in Algebra 1. If I take negative 5 to an even power, I'm always going to get positive. If I take it to an odd, I'm always going to get odd. So what I like to do, instead of trying to remember what's what, just put that negative number in parentheses. That way I don't have to worry whether it gets that odd or even. Okay. X to the 6 times 4. X to the 24. Y to the 3 times 4. Yes. Which one? 21 I have. Let's see. First of all, I'm going to put a 1 at that 2. I'm just going to distribute that 3. The other 21. Oh, this 21? Okay. You didn't specify which 21. Sarcasm. Joke. Okay, so 2. How about this 21? Yeah, that's another variable, so let's put a 1 there. Five times 2, x to the 5 times 1, and z times 2 times 5, 10. Yeah. Like I said, if there's anything in there without a exponent, it's 1. Okay. Think you guys got it? Let's leave the fractions alone for now. Okay. So you got 2 pages to do, 20 minutes to do it in. Shoot it.